Ever since we started managing us.
Hey, dude.
Hi, guys.
Ben, you're muted if you're trying to talk.
I thought I hear something.
Maybe I would say no.
Yeah. No. Go ahead, guys. I don't know if anyone's going to be joining, but I think it'd be great to walk through the stuff Meng's been doing.
All right.
Yeah, I also haven't looked at it yet, so.
We should probably reboot this meeting and maybe have a working group that's like got a clear mission or something. Like develop, like, I don't know, coding stuff or developer work productivity or something. Because right now, I mean, people don't really know what top kinds of things land on this agenda. What's appropriate for it. I don't know who's interested in driving that meeting, but
Wait, like a new working group meeting that.
yeah, a working group around this.
Yeah.
Like the other ones. This is like a remnant pre-working group.
Right.
Kind of thing.
Yeah.
So I just noticed that there's a link to Jude's email to RSVP come to the office. It's already updated that. I know.
Yeah.
I would add, I guess, in-house email, or I know who wants to take your office. It's too late now. But if someone sent an email, try to RSVP.
Yeah.
The next time it gets copied and pasted, will be an hour.
Is it recording? Why says it's recording?
I think they all looked like that.
Okay.
Yeah, I'm gonna
That's that real quick. Get a better rush.
Do you guys mind if I crack that window?
Yeah, sure.
Yes, I don't.
Oh, it's pretty loud right there.
Yeah, you.
That's
the window or
really loud.
Air conditioning units and stuff.
Not too loud. There we go.
All right, I think let's get started maybe. Sure. After customer time.
Hey, are you guys able to hear us, or is the background noise too loud?
Hey guys, sorry. I just got a call. Give me, well, why don't we start, and then I'll be back. I'll be here, but I think we should start.
Okay.
Okay, I will present the allocator benchmarking results I've been doing. Let me first share my screen. Okay. All right. So lately, there have been several performance improvement patches been landing to the allocator during the past couple of months. And so I decided to do a benchmarking across the previous several releases and to see where we stand. So it's a quick benchmarking. I just benchmark to use one particular test, the hierarchical allocator decline offers. So what it does is simulates a number of frameworks that have a fixed amount of work to do. Once they have reached their targets, they start declining all subsequent offers. So this test is built with optimized build with CLAN and run an idle quad-core i5 machine. So I didn't repeat the test, but I fixed the frequency. So the result is fairly stable. The setup is the data here shows 1,000 agents with 50 frameworks. And I only show the first 50 allocations. And no quota is set in this setup.
What's the decline timeout?
Okay, let me check. You mean the filter or?
Yeah, right. Refuse seconds.
Recover resources. Recover. Intmax. What is Intmax? Oh, Intmax. So forever, like
okay.
Something like that.
Yeah.
So we don't actually know here which cycle frameworks are done. Work. Like they don't suppress, they'll keep declining. We're going to keep seeing more filters.
Right.
Times might continue to change.
That's
we don't know when things, like everything could have finished in the first cycle. You're right. You don't know.
Everything could finish in the first cycle.
Like it says, number of frameworks have a fixed amount of work to do. Once they reach their targets, they start declining all of them.
Right. Looking at times to get offers all the resources.
So the most interesting one here is probably the first cycle test.
I have to admit, I didn't go through the benchmark code itself, but now I look at it, it seems like the framework just keeps declining.
So never much anything.
Yeah, it's always declining. Yep.
So it's more like what.
But we still need to make
what happens as we build up more and more filters.
And also we need to make allocations, right? Other than the accept, I don't think it's any fundamentally different from a normal allocation cycle. We still have to go through all the logical paths, right?
Do we even make offers?
We make offers, yeah.
How do you know?
So, well, there are a lot training out. Maybe let me share my full screen. Let me share my full screen. Okay.
So, perfect timing. I just got back and now you're showing stuff.
Sorry. So yeah, it prints out slots like this. So each allocation we make, I think we always make offers after filtering out something like that. This is the code. So loop enough times for the frameworks to get offered all the resources.
Excuse me.
And we always the way that we treat the offer is we always decline and set up the max refuse seconds, and we just keep doing that. So I think each time, each framework will decline one agent forever. So theoretically, this
since we have 1,000 agents, it takes like 1,000 cycles for each framework not getting any offers at all, I think. So I measured I only measured the first 50 cycles. Basically, I think although like it has this weird behavior of keep declining offers, it basically has the same logical path as a normal allocation cycle.
So these frameworks are not starting any tasks.
It's not starting any tasks.
So, okay.
I mean,
I was confused by it says it's simulating them having a fixed amount of work to do. So yeah, basically it's simulating frameworks that are always declining all the offers.
So this is like benchmark in allocator with it doesn't involve like master or task launch. Mm-hmm. So I think the cluster started with some resources already allocated. I think it's in a sense like we simulate frameworks that have fixed amount of work to do, which has already been launched. So there are like maybe half of the resources are already allocated, although there's no tasks launched or anything. Okay. And so, then we start to.
Okay. So what we're measuring here is how the allocation cycle latency changes as more filters are added, right?
You can say that, yeah, that is correct. But I'm also saying that this is also similar to what happened when you do normal allocation. Yeah.
They would be similar to what happens unless you're suppressing. So without suppression, this would happen. Yeah.
So it's basically simulates as faster without suppression.
Gotcha. And there's no churn. The tasks run forever.
No churn. Like there's no task actually per se. Like it. So the way that we simulate to have a fixed amount of work to do is just make half of the agent resources as allocated. So in the hierarchical allocator benchmark, there's no
right. So I guess by that I mean we don't recover resources ever. Is that accurate?
Right.
Okay.
Yeah, we assume they just run forever. Yeah. Okay, so here are the results. So two graphs, but they are the same data. So this is the y-axis is the allocation cycle latency, and the x-axis is the allocation cycle. So I measure 50 allocation cycles, and we compare four different builds: 1.5, 1.6, x, 1.7. And the last one is the current master plus a copy on write optimization. So as we make go through the allocation cycles, more filters are built up. So the latency naturally increases. But we can see our optimizations are getting work done. So the latencies are like better across releases.
Do you know what happens here as you go past 50? Like, is this gonna skyrocket upwards? Like, what's so special between like 45 and like 40?
So why? Exponential. Yeah, why it looks like exponential?
Like it's pretty worrying. Like, what happens if you get to 60, 70? It's kind of funny. It's kind of surprising. Actually.
Yeah, I don't understand why that would happen.
That we happen to pick a number that corresponds with like when it starts to go 5x.
Like the critical point happens right at the end of this test.
Enough touch for that. Yeah.
Yeah, there doesn't seem to be any exponential stuff.
I guess we can try running the test for more duration and see how you have. Well, it seems like at some point we reach some number of filters and then
it's probably
it becomes exponential.
You can build up like because the problem with filters is in this cluster we could optimize it, I think. But normally you can actually get every permutation of resources filters on a box. You could have filtered like one CPU, then two, then four, and then permute that with like the different amounts of memory you get.
I think what could be interesting is having the x-axis the number of filters instead of like allocation cycle and see yeah how that maps.
So in this test, the number.
So here is the thing. Well, here is the detail log. So it doesn't seem the number of
Oh, it's 0. It stops making offers at that point because everything has been
declined.
Yeah,
everything has been declined by everyone.
but it takes us a very long time to do that.
Jumps up, yeah, it's interesting. You know, it's not a very long time. It's like 2x the previous time, which makes me think that like if you have a number, like it takes x to do something.
Mm-hmm.
And
Yeah, I
before
think
that,
it's already stabilizing here.
yeah, like it's stable there.
Saturated.
But when you go from 48 to 49 there, I would assume that in 48, like, how many agents are there?
1,000.
So in 48, half, you have like an expected randomness of like half. If you're picking one person, the expected distribution is like, if you average it all, it should be in the middle point. Some of them were on the end of the list, some of them were at the front of the list, and you pick some on both sides. And on average, like, if you averaged all those times of like, you did it really quickly because it was at the front versus you did it at the end of the list,
Yeah.
you end up with like, it averages out to if you picked everyone at the middle-ish. And then the next round, it's essentially everything's at the end. We go to the end and we didn't pick anything. So it becomes half x.
Oh,
x.
interesting.
That might be that what that jump is.
Interesting. Yeah. But nonetheless, from what, round 26, 27 to round 50, to round, yeah, up to round 50, we go up by like a factor of 10.
There's some filter optimizations we can probably do. So we might want to explore those based on this.
Also, it stayed stable afterward because the number of filters did increase. If there's nothing else to offer, we get that. If no offers were made, then it wasn't possible to add extra filters. Yeah. So it's not that I don't know, the performance.
Yeah.
But or something like that. It's like we with this configuration we can test more than 50,000 filters apparently. But we need to add more agents or something to be able to see how it scales to more filters.
It's really cool that we're getting what 50% improvement over 1.5 now.
Yeah.
Yeah, so that's the number here. Like this is normalized latency to 1.5, and yeah, so we are making progress across releases
For this benchmark.
for this benchmark. Yeah.
I think in practice, this benchmark, there's no reservations or any metadata resources.
Yeah. Right.
So resources aren't that expensive to copy compared to clusters where people put reservations with like labels and all sorts of stuff in there. That's like really expensive.
So we're saying
Is it that much expensive?
It's a lot.
Are people using large labels or something?
In DCOS,
Yeah. We saw icons in
resource labels though?
Oh no, that's in task labels.
Yeah.
Yeah, right.
reservations labels, we have things like IPs and things.
Yeah.
But in metadata, that's very substantial.
I guess I thought that like SDK would just tag one unique ID per resource or something like that. Or per reservation, I mean.
Maybe, I think it's more than that.
Okay.
yeah. So I guess you're saying in practice we'll get more than this benefits.
Maybe, it's just might be different.
Also, like when quota is involved, we will also get like much more percentage improvement because we're doing like more computation.
But this is good. I at least have some grasp. We do need to publish the performance blog post soon. I can put some in there. I probably won't put that one on the left in there.
I think
Just ended it for you.
if you add more allocation settings, basically it would stay at that. Like it would go there and then because there are no more filters to add.
Right. Yeah.
Yep.
So it won't keep growing. You have to.
Yeah, I just randomly picked 50. To be a good number.
Oh, did you stop it at 50?
Yeah, I stopped at 50.
Okay, but in the logs it kept going a couple more times.
Right.
So it would have, okay.
So I hiked the interesting.
Oh, right. Yeah, we missed the plateau here.
Yeah.
But it's interesting that talking to one user recently, they seem to have actually noticed that there were some performance improvements to the allocator without us really having to communicate it too much. So it must have actually impacted them.
That's great.
Improvement.
Good words.
Yeah. Yep. Okay. Yeah, that's all I have. Yeah, so this is just a preliminary application benchmark. We are working on some like more comprehensive ones, also including Coda. And stay tuned. That's all.
Well, it's exciting. It's exciting to see this stuff getting improved, huh?
Yeah.
Yeah, we're not done either.
I know.
We're stuff.
Wait, there's more.
That's the best part. Yeah, that's the most exciting part. Yeah, no, it's really good. Okay, well, thanks for presenting that stuff, Meng.
Sure.
I appreciate it. I have a feeling that there was a different protocol when Judith was here for getting people to join these meetings, because I don't think anyone else joined.
Yeah, she was pinging everyone, asking them to present, and then finding ingredients. So it was more active, basically.
Yeah.
Okay, I'm gonna chat with Matt Jarvis a bit about having someone step in and help do that.
Well, maybe this meeting should become like a working group that's focused on something. Because like honestly, this presentation that Meng did, we would do it during the performance one.
Yeah, makes sense.
Yeah,
I mean, I don't think we need this meeting per se either. I think it was just an opportunity for anyone to be able to come and chat about stuff. And so maybe the right thing is to just keep pushing hard on the working groups right now, rather than trying to focus on a catch-all.
Yeah, and probably the gap right now is like, we don't have one where we talk about programming C++ and Mesos and stuff, like the build and the abstractions we have, and libraries, new abstractions we've added, and tests and stuff.
Yeah.
There's probably some room for that.
I think like one catch-all that we have is a community working group in some sense, where we talk about lots of the stuff that doesn't fit in any particular working group, though we mostly focus on stuff around community interaction contributions, but that's another catch-all kind of working group where we could actually, that's where we kind of talk about other working groups that we could spin up when people start talking about it. So we do have that.
I have something off topic.
Okay, we put it together.
It's just an announcement. Like the CFP for MesosCon was extended until Tuesday. And if you don't want to travel to New York, you might not have to. Like it's very likely that we will move the conference to San Francisco. It's mostly a done deal. When the announcement will be sent tonight. So if you haven't submitted anything yet, please do. Okay. And the format of the conference will be different than the previous MesosCons. This will be a user conference, so it will be more for the community, by the community. So if that appeals more to you, then that would be great for you.
Cool.
I will submit one for the performance working group, I guess.
Okay, I'm back. Sorry.
Sorry?
Hello?
Hello?
Did I lose you?
Hi.
We're here.
Hello?
Hello. We can hear you.
Okay. All right. Oh, gosh.
Someone had mentioned, I can't remember who it was, maybe it was you, Gaston, that you might want working group leaders to do like summaries at some point. Is that something you talked about?
Yeah, we talked about that. I think was going to talk to people. So one of the ideas is to have a presentation per working group to see what's new, what's in the roadmap.
Submit a talk, or there be more structure, or just.
I think we wanted to have, like, give each working group an opportunity to present what's been done, what's on the roadmap, and then talk, like, have an in-person meeting or something like that. We haven't fully defined the format. It would be like giving each working group a slot to talk to.
So don't submit a talk then? Working groups yet? Or just submit one anyway, and if we change it, we can.
Yeah, I mean, if you submit one anyway, yeah, we'll be. But yeah, if it's going to be about what's new in the working group, don't spend a lot of time on the abstract. Just like say more or less what Alicia said. If you want to present something else, then yeah, maybe expand on that.
So September 4th, that's right after the long weekend.
Yeah, it's a whole Tuesday. Then so they have an extra day after the weekend.
Yeah, I hope people are not taking an extra day off for adding to the long weekend. Then. Okay. Cool.
Yeah. The location change will be most probably announced tonight as well. Yeah.
I guess I need to change my tickets now, huh?
Yay.
That I kind of back channel to know the hotel and everything and book my tickets, and now it kind of blew back on my face. Okay.
So
right. I was trying to save some money for the company, but it looks like more expensive.
Oh, no. This is still going to save money for the company. Less people will be finding
Oh,
out.
yeah. I guess on aggregate, yeah.
This is a recorded public meeting.
What did you say, Ben?
Recorded public meeting.
All right, this is public
That's
meeting.
true.
All
Oh,
right.
you probably want to delete. You probably want to.
Well, that's not why the decision was made, though. But will still be cheaper. Okay. All right. Anything else we want to cover?
Not on my end.
Okay. Cool. Awesome.
Okay.
Sweet.
Talk to y'all later. Okay.
Later.
See ya. Bye.
Man.